In this lesson, we are going to look at inequalities. And as usual, just before we get started, I just want to remind you on how to do mathematics. So make sure that you understand each step in the examples. Then you will not learn how to do maths by reading it or watching someone else explain it to you. Understanding the steps does not mean you can do it on your own yet. Therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers when they ask you to pause. And then you improve your skills only through practice, but more specifically, marking your practice sums and learning from your mistakes. Okay, so an overview of this video is going to be divided into two sections because inequalities has two ways of doing them. So first we can look at the graphical method, and then we are going to look at the algebraic method. So for the first example, now before we get started, when we do inequalities, inequalities are solved exactly the same way as you solve equations, except when we solve for an equation, and specifically this one, well, first of all, we need to put it in standard form. That's the first step. So if we do that, we have x squared minus x plus 6. We multiply out the brackets. So 2x plus 4. Take everybody to the one side because this has a quadratic in it. So it's a quadratic inequality that we are solving. So x squared minus x minus 2x plus 6 minus 4 is less than 0. And then add the like terms. X squared minus 3x plus 2 is less than 0. All right, now, as I was saying, when we solve for an equation, what we do with this type of quadratic equation, this is a quadratic function. And when we have a quadratic function, what we do when we solve for this quadratic function is we are basically just looking at where does the graph cut the x-axis. So that's when you solve for x squared minus 3x plus 2 equal to 0. That's where it's equal to 0. But with an inequality, we are just being asked where's the graph less than 0 or greater than 0. In other words, where does the graph lie below the x-axis, or where does it lie above the x-axis? Now, the first step was basically to put it in its standard form, as usual. Then the next step is we need to find the roots. So the roots is basically solving the equation, where we have x squared minus 3x plus 2 being equal to 0. So first thing we do is we factorize it. X minus 2 and x minus 1. Just taken the factors of 2 and to get minus 3. This is basic grade 9 work. And then less than 0. And then our roots equal to 0, because this is just solving for the equation. Then our roots is where x is equal to 2 or where x is equal to 1. So the function would actually look more like this, where it cuts, both roots are positive. So this would be 1 and this would be 2. Then we are asked where does the function, or where is it less than 0? So meaning where does it lie below the x-axis? So that means it's this part over here. Right, that's where your graph is negative. And another thing to take note of is it asks us where is it less than 0, not where is it less than or equal to 0. So that means that the two roots are not included. So how we're going to write this is just going to say if x lies over here, then from 1 to 2. So when you write an inequality and it lies between two values, you can always use this standard as 1 will always be less than x. You can see 1 is always less than x, and x will always be less than 2. X is always less than 2. It's never on that side. And when you have an inequality and you always have it between two values, then you can use this. All right, and then just a final thing, if they had said that it's less than or equal to 0, that would have included the roots. Then we just have a less than and equal sign for both of these. Right, so for question 1.1, first thing we're going to do obviously is just put it in its standard form. 2x squared plus 3x minus 20 is greater than 0. So I basically just took these over to the other side and changed their signs. Next thing to do is to find our roots. So that is basically to solve for 2x squared plus 3x minus 20 being equal to 0. And to factorize, we have to use the XL method because we have a coefficient in front of x squared. So you can either use the grouping method or the extra large method. So you have factors of 2, 1 times 2, and on the side factors of 20, 1 times 20, 2 times 10, and 4 times 5. Okay, and what we want to get is plus 3. This side we just flip around, 2 and 1. Okay, now we start. So 1 times 20 is 20, and 20 and 2 won't give us 3. Then we have 10 and 4, that's going to give us 3. Then we have 5 and 8, that might work. So 2 times 4 is 8, and 1 times 5 is 5. To get plus 3, I'm going to say plus 8 minus 5, so positive, and then negative over there. And then we have x plus 4, and this side we have 2x minus 5 equals 0. So our roots are x equals to minus 4 or x equals to 5 over 2. Right, next we have to draw our graph. Now we can see that this is a positive graph because the coefficient of x squared is positive. So we're going to have a happy face. And then the roots lie, one is negative, one is positive. So we'll have, it doesn't really matter to put the y-axis in, but we can just do that. So this is where minus 4 lies, and that's where 5 over 2 lies. Now, importantly, it says that this 2x plus 3x minus 20 is greater than 0, meaning where is it above the x-axis? It's over here and over here. So going to infinity, from there to infinity, from there to negative infinity. So in terms of x, we have all of these x values going to negative infinity, all of these x values going to positive infinity. X lies here and x lies here. Right, so x is less than minus 4. So x is less than minus 4. And notice it says only greater than 0. So meaning we're not going to say the 4 and the 502, the roots are not going to be included because the inequality is equal to 0 on the roots, but this time it's not included. It's just greater than. So on this side, x is greater than 5 over 2. Yeah, and then we're done. Okay, now to put this guy in standard form, we need to multiply out this bracket. So 2 ways to do that. You can either write them next to each other, 2x minus 3, 2x minus 3, or we can do it the fast way by just saying square the first one, 4x squared, multiply together, multiply by 2. This is negative 6x times by 2 is negative 12x, and square the last one, plus 9, is less than 4. Bring the 4 over, 4x squared minus 12x plus 9 minus 4 is less than 0. 4x squared minus 12x plus 5 is less than 0. Okay, finding the roots. So solving for x squared minus 12x plus 5 equal to 0. Factorize. So once again we have the trinomial factorization with a coefficient in front of the x squared. 1 times 4, 2 times 2, and on that side it's just 1 times 5. This side we can just flip around 4 and 1, and I'm looking for negative 12. Alright, so 4 and 5 won't give me negative 12. 10, 2 times 5 is 10, and 2 times 1 is 2, so that's going to work. So 2 times 5 is 10, and 2 times 1 is 2. In order to get negative 12, I must say minus to minus 10. Negative negative. So I'm just taking this minus over that side, this minus over this side. And our factors are 2x minus 1 and 2x minus 5 equal to 0. Right, so x is equal to a half, or x is equal to 5 over 2. Now, once again, we can see the coefficient of x squared is positive, meaning our graph is happy. So we have the graph lying here. Now, notice both are positive roots, so I'm just going to draw it more or less here. Don't have to be an accurate drawing, just more or less where it lies. And then half and 5 over 2. Okay, so it says where's the graph less than 0, meaning where does the graph lie below the x-axis? So that's all the way from a half to 5 over 2. So in terms of x, it's just going to be these values over here. Now x lies between these values, so it's going to be a half is less than x is less than 5 over 2. Right, now putting this guy in standard form, not always obvious, but we can put brackets around this one and put brackets around this one. And in order to get rid of fractions, we just remember we have to multiply all the terms by the lowest common denominator, which in this case is just x minus 3. So either think about it like a cross multiplication where you just multiply this up, or just think about it with multiplying this term with x minus 3, this term with x minus 3, and either way it will end up with 6 is less than or equal to x plus 2 and x minus 3. Okay, multiply out the brackets. X squared minus 3x plus 2x minus 6. Bring everybody to the left hand side. So minus x squared plus 3x minus 2x plus 6 less than or equal to 0. And add like terms. Plus x plus 12 less than or equal to 0. Alright, now at this point, this guy is negative. And we can try and factorize it like that, but it's actually easier to just get rid of the negative coefficient before factorizing. What that also means is if we get rid of the negative, our graph will automatically, if we always get rid of the negative, our graph will always be positive. But that's up to you. I just think it's way easier to factorize it if that is a positive. So what I'm going to do is I'm going to divide everything with a negative. So this becomes x squared. This will then become negative x. This will become minus 12. And very important, if you divide an inequality with negative, the sign changes. So that becomes greater than or equal to 0. And then we can find the roots. So finding the roots, solving for x squared minus x minus 12 equal to 0. Factorize. Easy factorization. Factors of 12 to give me minus 1 is 3 and 4. So x minus 4 and x plus 3 is equal to 0. X is equal to 4, or x is equal to minus 3. Now we can draw our graph. One is a negative, one is a positive. So I'm just going to draw it like this. And then we add negative 3 and add 4. Now the question says, where is the graph, this final one, greater than or equal to 0? Meaning, where does the graph lie above the x-axis? Over here and over here. Remember, this is your x-axis, just in case. Then it means that the graph is going this way forever, and this way forever. So x lies here and here. Meaning, if we put that into the inequality notation, x will be less than or equal to, because now it says greater than or equal to 0, meaning our roots are included in this one. X is less than or equal to negative 3, or x is greater than or equal to 4. Right, graphical method is done. Now let's look at the algebraic method. First example. Now we can choose which method we want to use, but in this case we will be forced to use the algebraic method. But I must say I haven't seen a lot of these sums in past papers, but they can be there. So we also need to factorize it completely. In this case it's easier because these are already in factored form, except for this one can just go further and say y plus 4 and y minus 4. So also just important is our roots will then be x equals to minus 4. That's if I solve for each of these factors individually, putting them equal to 0. X is equal to 4. Minus y, 2 minus y, take the 2 over, it becomes a negative. So then you'll have y minus 2 equals to minus 2. Divide both sides by a negative, so you'll have y equals to positive 2. So that's the one root. And the last one, y is equal to negative 2, because if you put this equal to 0. But very important is that this guy is not allowed to be 0. So that's the only root that it cannot equal to. So, but it's still part of our root. It's just going to be that in the final answer it can never be equal to that root, because this would make it undefined. If you have a fraction over 0, that's undefined. Okay, so now here's what we do. We are going to draw like a table, and then in this table at the top part we are going to list the roots, and on the side part we are going to list the factors. So for every root we just have to draw a line like this. Okay, we have to arrange them smallest to biggest, the roots. The factors doesn't matter, but the roots must be smallest to biggest. So we have minus 4 first, and then minus 2, and then 2, and then 4. Okay, and then we can just list our factors: y plus 4, y minus 4, then 2 minus y, and y plus 2. Okay, now what we do is now we need to just determine what sign or what the signs are. So if we start with the first factor, if I substitute, so these are like a number line. You can look at this as a number line. So anything that lies here is like minus 5, minus 6, minus 7. Anything that lies here is between minus 4 and minus 2, and so on. And then over here 5, 6, 7, and so on. Now if I substitute any number over here into this factor, let's say minus 5. So minus 5 plus 4 gives you negative 1, which is negative. If I substitute anything between minus 4 and minus 2, let's make a number up. Minus 3, any number, minus 3. Minus 3 plus 4 is plus 1. That would give you a positive number. Between minus 2 and 2, that let's say 0. You can say 0, 1. If we put in 0, we get 4. If we put in 1, we get 5. So that would be plus. And between 2 and 4, 3, that gives you plus. And 5 plus 4 is 9. It's a positive. Okay, and that's the first row completed. But there's an easier way than to check it for each of these factors. What you need to remember is that it starts with a negative. And then because the factor, when you substitute its own root in, it will be 0. So anything below the root will be negative. You can just test it to be sure if you doubt yourself. So for example, 1 minus 4 gives you negative 3, gets negative. But on the root, if you substitute in the root into its own factor, you're going to get 0. And then anything bigger will give you a positive. So this one, the root for this one is the plus 2. So anything below will give you a minus, and then once you've reached the factor's own root, it becomes 0, and then it turns into positive. And this one is minus 2, so minus its own root, and then positive. Okay, so once you've completed that, next thing you do is you're going to multiply the signs, because basically we want to know, is this entire what do you call it, graph or expression, is it below -4, is it going to be the entire thing is going to be a positive or negative? And now we've just broken it up in its factors and checking the factors individually and then multiplying the signs of each factor together. So a minus and a minus is a plus, a minus and a minus is a plus, and a plus and a plus is a plus. So opposite signs, negative, same signs, positive. And then opposite signs, negative. So this becomes a minus and this becomes a minus. Minus and a minus gives me a plus. And then minus and a plus and a minus is a minus, and a plus is a plus. That becomes a negative, and then that's going to be plus. All right, so next thing, if you remember drawing number lines in earlier grades, then you use dots, and an open dot means the number is not included, and a closed dot means it is included. Now in this inequality it says greater than or equal to 0, so that means your roots must be included. So they are all included except for one, and hopefully you can guess which one, the one that it cannot be equal to. So this is then where -4 is included, so we can just color that in. -2 is not included, this is included, and this is included. Next we look at, do they want the positive values or the negative values? So greater than or equal to 0 means the positive value. So where's the graph positive? It's positive over here, over here, and over here. So from negative infinity, or going to negative infinity, between these two values, -2 and 2, and from 4 to positive infinity, those are where the graph will be positive. So x lies over here, x lies over here, and x lies over here. Right, now the final answer, just because I've run out of space, I'm just going to write it here at the top. The final answer will then be where you can see here x is less than -4, or less than or equal to -4. So x is less than or equal to -4, or x lies between these two values. So from -2 being less than x, only less than because it doesn't include -2, x is less than or equal to 2, or x must be bigger than 4. X is bigger than or equal to 4. Yeah, that's the final answer there. Okay, now if you recall, this was just the first example we did when we used the other method, not the algebraic method, the graphical method. So now let's look at how to do it using the algebraic method. First of all, we once again must put it in standard form. That's always the first step. 2x plus 4, bring everybody over, x squared minus x minus 2x plus 6 minus 4, less than or equal to 0, or less than 0, and then x squared minus 3x plus 2, less than 0. Okay, and once again we need to find the roots. That's also basically standard in both. We're solving for this equal to 0, so let's just factorize that. It would be x minus 2 and x minus 1, less than 0. Oh, sorry, equal to 0 because we're finding the roots. And then x is equal to 2 or x is equal to 1. All right, now instead of where we would have drawn a graph for the graphical method, now we're just going to draw this table. We have two roots, meaning we're going to draw two lines over here. And we list our roots in order from smallest to highest, ascending order 1 and then 2. And then our factors over here, x minus 2 and x minus 1. Right. So x minus 2, it's going to be negative, negative, positive, because on 2 it's going to be 0. And then negative, on 1 it's 0, and then positive and positive. Minus and a minus is a plus. Minus and a plus is a minus. A plus and a plus is a plus. And then we look at what it asks for. Less than 0 means negative values. So basically it's from 1 to 2. Between 1 and 2, the graph will be negative. And then less than 0, meaning it doesn't include the root, so we keep it open. So x lies over here. So we can just end off by saying 1 is less than x, x is less than 2. Right, question 1.2. So just factorize this completely. We take out x, 2x minus, okay, wait, this is 2 minus x. All right, and then over x plus 5 is less than or equal to 0. Right, and then our roots will be where x is equal to 0, or where if I take the 2 over, it becomes a negative, divide both sides by negative, x is equal to 2, or where x is equal to minus 5. Now just pay attention, once again, this is in the denominator, which cannot be equal to 0, so x can never be equal to minus 5, because remember, if you substitute in the root into the factor, minus 5 plus 5 gives you 0. Alright, we have the roots. We can now just draw our table. We have 3 roots, so we're going to draw 3 lines over here and list them. So minus 5 is first, then 0, and then 2. Right, then we list our factors. So x, then 2 minus x, and then x plus 5. Right, x starts negative, negative, or at 0 it's 0, and then positive, positive. 2 minus x, negative, 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 positive. X plus 5, negative, positive, positive, positive. Okay, multiply the signs. This becomes a plus, and then plus and a minus is a minus, and then this becomes a plus, plus and a plus is a plus. This becomes a minus, minus and plus is a minus, and that becomes a plus, then plus and plus is plus. Alright, less than or equal to, so meaning our roots are included except for the negative 5 one. So this is going to be closed, so we're including those roots, and we're asking for less than or equal to 0, meaning we're looking for the negative values. So this way, that's the negative, and between these two roots is a negative. Okay, and then we just write it down. So x lies over here and x lies over there. X is less than minus 5, x is less than minus 5, or 0 is less than or equal to x, x is less than or equal to 2. Done. Okay, final question. We have 2 trinomials. The top one, which both needs to be factorized. So the top one is just going to be a bit harder because it has a coefficient over here. So you can use the Excel method. 1 times 6, 2 and 3. On this side, 1 times 5. Let's swap these two around. 6 and 1 and 3 and 2. And we want to get plus 13. Okay, so 6 times 1 is 6, and then that's 5. That gives us 11. 2 times 5 is 10, and 3 times 1 is 13. That's going to give us 13. So we have 10. Say 2 times 5, 3 times 1 is 3. To get plus 13, I must say plus 3 plus 10. Okay, but that's a problem because this is a negative. So the signs cannot be the same. So there must be another option. If I say 6 times 5, that gives me, what does that give us? That gives us 30 and 2, that's too big. And then 3 times 5 is 15 and 2. So this is actually our real roots. 3 times 5, those are a pain. Okay, so 2 times 1. Okay, 3 times 5 is 15 and 2 times 1 is 2. So to get 13, I must say plus 15 minus 2. So put the minus over here and the plus over here. Our roots are 3x minus 1 and 2x plus 5. And that's over. Now this one's easier to factorize. So 2x, factors of 3 to give me 2, just 1 times 3. So I'm going to say x plus 3 and x minus 1. And it's greater than 0. Okay, roots are now obvious. So roots are x equals to 1 over 3, or x equals to negative 5 over 2, or x equals to negative 3, or x equals to 1. We draw our table. Okay, and we have 4 roots, so we're going to list 4 lines over here, and we're listing them in ascending order. So starting from the smallest one, which is minus 3, then negative 5 over 2, then 1 over 3, and then 1. Okay, and then we have 3x minus 1, we have 2x plus 5, we have x plus 3, and we have x minus 1. Right. Now over here, 1 over 3, this is its root, so minus, 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 plus, plus. 2, if we're looking for negative 5 over 2, that's the root, so minus, minus, plus, plus, plus. And this one lies here, minus, plus, 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 plus. And that one lies all the way at the end, minus, 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 plus. Okay, minus and a minus, plus, minus and minus, plus, plus and a plus, plus. Minus, minus, plus, plus and a minus, minus, plus and a minus, minus. Okay, minus, minus, and plus. Plus, minus, and minus. And that's plus. All right. Now, greater than 0. So, first of all, roots not included. So, we can just draw this as open dots. Greater than 0 means your positive value, so it's going this way, and then between those two values, and then all the way that way. So that's positive, positive, positive. So x lies over here, and over here. Then we can say that x is going to be less than this root, so x is going to be less than minus 3, or x is going to be lie between these two values. So from minus 5 over 2 less than x less than 1 over 3, or x is going to be greater than 1. Right, and that was the algebraic method. Then we are done.